All right, what's up, everybody? It's Professor Ben Nasul, and today we're going to be doing Chapter 3, Section 5 from the Open Stax textbook, which you can find online for free. This section is called Freefall, and the book defines freefall as any object falling without air resistance or friction. Obviously, the acceleration is the acceleration due to gravity, which allows us to apply the kinematic equations of any fallen object, where, again, air friction and air resistance and friction are negligible. So without further ado, let's jump straight in. While riding in a hot air balloon, which is steadily descending at a speed of 1.51 meters per second, you accidentally drop your cell phone. After 4 seconds, what is the speed of your cell phone? How far is the cell phone below the balloon after this time? And part C is what are your answers to part A and B if the balloon is rising at 1.51. Okay, so basically part C wants us to do everything all over again, but with the balloon going up. So let's get started with part A. Let's find the velocity or the speed of the cell phone after 4 seconds it's been dropped. So we have our hot air balloon, which is descending at a rate of v. We're going to let the initial speed be v sub 0, which is going to be 1.51 meters per second. And we have our cell phone, which fell. Now, because the balloon is descending and because the cell phone has fallen, we're going to put a negative in front of the initial velocity. So using the kinematic equation of v final is equal to v0 plus gravity times the change in time, we're going to find the final velocity when t is equal to 4 seconds. So the initial velocity, again, we're going to put a negative in front of it because the balloon is descending and the change in time is 4 seconds. So after you put all that in your calculator, you should get negative 40.71 meters per second. But remember that velocity is always positive, and we can round this up to 40.7 meters per second. So that is the velocity of the cell phone as the balloon is going down. Now, part B wants us to find how far the cell phone is below the balloon after t is equal to 4 seconds. So let's keep in mind that the balloon is descending. So the balloon has descended some distance that we don't know. And so the distance that they want us to find is this distance right here, which is going to be the blue distance minus the red distance. So we can use the kinematic equation y, that's y1. y1 equals y0 plus the initial velocity times the change in time plus 1/2 times gravity times the change in time squared. So if we place the origin right here, then up is positive and down is negative, which means that that is 0. So our initial position of y0 is 0 plus, again, we're going to use our velocity that we found right here, and it's going to be 40.71 times 4 minus 4.9 times 4 squared, because gravity is the constant of negative 9.8. That's so, I apologize about that. G is negative 9.8 meters per second. So that times 1/2 divided by 2, or divided by 2 is the same thing as saying multiplied by 1/2 is equal to negative 4.94 squared. So after you put that into your calculator, you should get the distance that the phone has fallen, which is 84.44 meters. Now, if we take a look, we want to know what is the distance after 4 seconds when the phone has that velocity. That is why we let v sub 0 be 40.71. Now, let's find the distance that the balloon has covered in 4 seconds. So we know that speed is equal to distance over time. So solving for distance, we have speed times time. And the speed that the balloon is descending with is 1.51 meters per second times the time that we want to find how much distance it has covered in that time with that speed. So that should be 6.0. I should do that in red. So that should be d is equal to 6.04 meters. So our distance from the phone to the balloon is going to be the subtraction of the blue distance minus the red distance, which should give us 84.44 minus 6.04 should be 78.4 meters. And that is for part A and B. Now, part C wants us to do everything again, but the balloon is rising. So let's draw another picture. Let's separate this. So now we have the balloon that is now rising, and we're going to find the velocity that the phone has fallen with. So what do you guys think? Is the phone going to fall with less velocity or with more velocity now that the balloon is rising? Well, let's find out. Our initial velocity is the same, I believe it said. Yep, it's 1.51 meters per second. So using our kinematic equation, we're going to find that the velocity, it's now positive because the balloon is going up, not down. Putting that in your calculator, you should get negative 37.69 meters per second, but velocity is always positive, so rounding that up, you should get 37.7 meters per second. And that is the velocity that the phone has fallen with after t is equal to 4 seconds. So as we can see, it does fall with less velocity when the balloon is going up, because in the first part, the balloon was going down and it had a velocity of 40.7, but now that the balloon is going up, it has just a little bit less of velocity. So now let's find the distance that the phone has covered. So y1 is equal to y0 plus the initial velocity times delta t plus 1/2 delta t squared. So we know that our initial position is 0. We want to know the distance that the phone has covered at that velocity, when it has that velocity of 37.69 after 4 seconds minus 4.9 times 4 squared, and after you put that in your calculator, you should get a distance of 72.36 meters, which, if we compare to the first scenario, the phone, as the balloon is going down, the blue distance is 84.44 meters. It's almost like the balloon is giving it an extra push. And when the balloon is going up, the phone covers less distance, a distance of 72.36 meters. So now they want us to find the distance from the phone to the balloon when the balloon is rising. So this is the case where we're going to add the distances, because they want us to find from here to the phone. They want us to find that distance right there, which is going to be the sum of the blue distance that we just found plus the sum of the red distance, which is the distance that the balloon has traveled. So again, we know that speed is equal to distance over time. So multiplying time by both sides, we get distance is equal to speed times time. So essentially the speed is 1.51 and the time is 4. So we get 6.04 meters. Now, the distance from the phone to the balloon is going to be the sum of 72.36 plus the distance of 6.04, which gives you a total of 78.4 meters. So if we compare to the first scenario, the only thing that has not changed is how far the balloon has traveled. When the balloon is descending, the balloon covers a distance of 6.04. When the balloon is ascending, the balloon covers a distance of 6.04. The only thing that changes is the velocity of the phone and the distance that the phone covers. When the balloon is going down, the velocity is greater and the distance is also greater than when the balloon is going up. Thank you, ladies and gentlemen. That is all for today.